And then ask your question while we move towards the.
I believe Ruben is going to take 2 observations half an hour apart in different filters for every field, right? Eric has left the room, but my understanding is that, yeah, I think it's 100% because this is part of their like object detection. And then for like 5 to 7% of the visits, there will be a third one 3 hours later. So I'm not so concerned about confirming something is real. Of course, like I think for 23XF, the thing was that like weather came in and so the telescope closed, and I can imagine that happening with Ruben too. But I do think that we will get pretty rapid confirmation. It will be a different filter. And so depending on SED, maybe you have a detection and a non-detection, but I think that that's not quite as dire as we think.
And it's better than that, right? What Nabil was pointing out is that you can combine Ruben with other surveys like ZTF and LS4 and whatnot, right? So then you can get your 2 points, which are longitudinally separated as well. So this game of, I think, finding younger supernovae can get really even younger. So with the combination of surveys, I think that's what Nabil was trying to get at right when he got cut off, if he wants to add more.
Okay, so we are now in the final discussions. Sorry? Okay, so this is a bit of a miscellaneous section. I think we have like talked about a very different things. So I think we just have there's some discussion points that people put on the slides, and I would say like just anyone that wants to comment on any of these points of any of the topics that we've discussed today.
Well, I can start by this the second one because it's also the one I had. So we keep trying to find more and more interesting things, right? We keep trying to find the weirdest and so on, but we are not always trying to do the deep or high cadence follow up to actually know the physics of this. And then, yeah, maybe I know we all know that we need to do better there, but I don't know if there is an actual strategy to do better.
Any comments? What do you mean by deep?
No, for example, Nabil presented a tool that does everything automatically and decides, okay, this needs follow-up, so let's take some observation of this. But then we always continue to find new interesting things. Well, I mentioned in my talk this as something that will be presented tomorrow, which is VH-TOM. That is also a TOM. Of course, I work on it, so this is why I mention it. But I think the main thing about this is that everything is public, so everyone can decide, okay, I need to follow up this with this cadence and so on. But we have too many candidates of things, but too few physical interpretation of things.
I think maybe this one, okay, there's a comment over there, but also like, I think this also goes into Jan's point over there. We have many, many interesting things, and with Ruben we'll be submerged with possibly interesting things. How do we figure out which ones are the good ones to follow up?
Yeah, I think that was basically my question or something to pose, because off of Priscilla's talk, like I know that people are trying to classify new things just in the limited LST, well, Ruben stream that we have, and some of them end up being these superluminous supernovae. Like I classified one of them by accident. It just happened to be one source that Priscilla's elephant pipeline presented, and it was superluminous supernova redshift 1. That's awesome. It's not my science, but I think that's awesome. But I'm just curious if we can start, if anyone wants to comment more on like the fact that that is like a very small fraction of the total amount of like interesting superluminous supernovae at high redshift kind of weird anomalies that we're going to find. So how do we as a community decide what things we go after spectroscopically? I know it's like a broken record for that, but now we actually are finding them, and there might even be already too many to follow up, even just in this tiny little sliver of the sky during commissioning cam phase. And I'm just curious if people have ideas or they're working on anomaly detections or things, or are the rates of some of these things actually low enough that we can manage with spectra? But, you know, I mean, a lot of us need like Keck time to do this, and that's nearly impossible to get. So people want to mention that or talk about that, I think that'd be cool.
Maybe one of the speakers wants to comment, or anyone else? This is a very tough question.
I think it's hard to give a generalized answer to that. It depends a lot on your science case, right? Like Priscilla's work, the elephant pipeline is fantastic because it finds the things without the hosts, and that's where the ones she wants to find are correlated with. You know, we do the infant supernovae cross matching to nearby galaxies because that's what works to find them. But it's you know, it's essentially impossible to give a generalized solution. There is work like to do large classification machine learning models, but typically the ones that are more narrow in their domain and focused on a specific science case are the ones that work better.
So did you say like, do we have enough spectroscopic?
Yeah. So like, what if I wanted, yeah, maybe this is a question for Priscilla. Like, what if I could give you all the spectroscopic resources? How would you decide how many elephant transients you'd follow up to classify?
Well, for a long time, we were reporting the ones we wanted spectra for, hoping for the community to get spectra. So we were reporting for quite some time. At the beginning, maybe the reports were a bit worse, but at the end, we became much better. But I think the main question is like, do we have enough spectroscopic resources? I think we do. What we don't have is enough coordination of these resources that we have. I think the resources are there. We just all compete for them instead of try to allocate the time in the most efficient possible way.
I just want to quickly address what Wayne was asking, whether we have enough spectroscopic resources follow up on subset of sources, right? The one, for example, for low redshift superluminous supernovae, just from ZTF experiment, we know we actually do have enough because it's a small enough that we're able to follow up spectroscopically in pretty complete sense. This is demonstrated by ZTF phase 1 data. I think by the time you reach redshift 1, I think this will be the next experiment that once we combine ZTF and Rubin, we will quickly reach that redshift range. I think in 1 year, we should be able to answer your question with the actual data to see how many such candidates per month or even, per week, we should be able to answer. For example, ZTF right now already able to find about redshift 1 around that number, just with the ZTF data, we have few already. So with the Rubin, we should know more. We just don't know exactly what the rate is yet. So I think this community will learn how to deal with this once we start learning about the results from Rubin.
Andrea?
So this is just kind of a dumb theorist question for the observers. So after some amount of time with LSST, we're going to learn a lot about stars. And so like, okay, so like Wynn is interested in 2P supernovae. 5 years ago, nobody cared about 2Ps, and now they're super interesting because we realize that, you know, maybe half of these 2Ps, their circumstellar environment. Sorry, no, I know, I've always loved them, but I just felt like we weren't getting love. But I'm just saying, like, so 2Ps are the unremarkable ones, right? But if with LSST, we know where the red supergiants, where are the red supergiants that are doing cool things, then if there's a bright event, do you take into account what we already know about the progenitor to say, we're going to follow up the vanilla things because there's these red supergiants that were doing cool stuff that maybe is associated with this late stage evolution and mass loss polluting the circumstellar environment. These are really critical things to learn about massive stars, but the transient itself is like a vanilla transient, not these very exotic things. So that's just kind of, I guess, maybe an argument for following up the things that we have seen a lot of, but like with 23 IXF, the exquisite detail of these things we thought we knew well is how we can learn about these very uncertain phases of massive stellar evolution, and maybe even the compact objects that they leave behind.
I guess I would just say to that, you know, there's many ways we can define things as exceptional. So it can be an exceptional data set on the closest supernova we're going to get for the decade, or it can be the most luminous supernova we've ever seen at redshift, whatever you want. And so, yeah, thinking about what are those sort of exceptional categories that are really worth prioritizing. And then we can argue about them, or yeah.
So I'll put one thing out there. What is exceptional is ultimately what you can convince ATT&CK to give you time for. And that is a fairly random process. So if folks haven't heard about the Gemini Observatory Rubin GEMS program, then maybe that's worth just a quick minute. So there is director's discretionary time from Gemini now for weird things follow-up discovered with Rubin. So it's Rubin GEMS. They can be extragalactic, galactic, true anomalies, or solar system objects. And this is a pilot program. It's a really good idea because it sort of is designed as a catch-all. The data is made available to the community basically as quickly as it's taken. And any program that already has a TO program gets priority override anyway. But you can also collaborate with the Rubin GEMS program to get multiple spectra for the same source if that's actually scientifically interesting. That is a good idea. We had to push to make sure that that program happened. And it would be a very good idea for other facilities to do the same thing. So if you happen to have a spectrograph on a facility like say Mount Lemmon or something like that, maybe convince ATT&CK to set aside some time for just follow up of weird stuff, wherever it comes from.
Okay, maybe the last comment before we.
I do like this idea of maybe moving towards a model where there is more approved time spectroscopically for the community. Like, I don't know, we're all probably working on Noir Lab proposals right now, but I think that there needs to be a little bit more of a community oriented thing in general. I know Space Telescope, we're trying to do the community TOOs, maybe we'll see how that goes, but just for things as uncostly, I guess, is just spectra time, which, could cost a lot depending on how much you ask for. But yeah, I think that there's a lot more movement maybe on the European side and stuff for that. But I think the US could benefit from more community spectroscopic programs like Rubin GEMS and other things where there are a lot of great science cases that the whole community can go in on. And then we just don't have to be putting in the same proposals and fighting over the same Noir Lab stuff, for Spectra or CAC, et cetera. I don't know. It's an idea.
Okay, very last one.
Oh, but there is a community supernova spectroscopic program that I think anyone is welcome to join on SOAR called PASTA. and Griffin is the PI. So I think anyone can join. And all of the, even if you don't want to join, all the data is public immediately. And we post all our spectra to TNS within hours of taking the data. So in that sense, there is a community program. We want everyone to join. I think many of the people in the room are already in it. And if you're not, please join us.
Okay, let's thank all the speakers and the people again.